Alright, welcome to Wisdom Analysis. My name is Wisdom Richman. So today we are going to treat nuclear chemistry as a part of topic 4 of the Jamb series based on the syllabus, and then we'll take past questions on topic 4 and that will be all. So hope you enjoy the video. Okay, radioactivity. Radioactivity is the spontaneous disintegration, in other words breakdown, of an unstable nucleus. Okay, so if we see an atom is made up of the electrons, which are in shells, and then in the nucleus we have the protons and the neutrons. So normal chemical reactions only involve the electrons, but anytime reactions involve the protons and the neutrons, this is no longer normal and it's called nuclear chemistry or radioactivity. So this is what we want to talk about today. Now, history of radioactivity. Henry Becquerel, around 1896, he discovered that uranium salts emitted radiation. Pierre and Marie Curie, they were a couple and discovered radium in 1898 and were also the first couple to win a scientific Nobel Prize. Okay, let's go to characteristics of radioactivity. Radioactivity occurs spontaneously and continuously until the unstable atomic nucleus becomes stable. 2. It is not affected by temperature. 3. It usually most times results in formation of a new atom. 4. Radiation affects photographic plates like visible light. 5. They cause ionization of gases they pass through. 6. It occurs with a release of large amounts of energy. Okay, let's go to types of radiation. That is, when radioactivity occurs, when an atom decays or disintegrates, how does it happen? What radiations are emitted? So the first is alpha particle. This is a helium nucleus emitted from the radioactive atomic nuclei. That is for example, radium. If it emits an alpha particle, that is, it removes a helium nucleus from itself. So since the atomic mass of helium is 4, so the remaining mass number will be 222. So this will be the mass number of the remaining one, and the atomic number remaining will be 86. So which element is this? This is radon. So radium, through radioactivity, has produced radon by releasing helium particle out of it, or we call it the alpha particle, out of itself. So let's take another example, that is uranium. So when it emits the alpha particle, that is the helium nucleus, you can see that the mass number is 4, so the remaining one will be 234, and the remaining atomic number will be 90, and this is thorium. So uranium produced thorium after releasing the alpha particle. Okay, so let's talk about the beta particle. This is an electron emitted by the radioactive atomic nuclei, and this is the representation. Okay, so it's emission of electron. Okay, so this is lead. If it emits the beta particle, you can see that the electron is -1, so the mass number is not affected, but the atomic number is now 83, because 83 and -1 will together give us the 82 of the parent nucleus. Okay, so this is now bismuth. Okay, so lead produced bismuth after releasing the beta particle. Let's go to the gamma ray. This is an energy emitted by the radioactive atomic nuclei in form of rays. So let's say this radioactive atom has excess energy, so it will become stable by releasing that energy in form of gamma ray, and then what we have left is the stable atom. This is how gamma ray occurs. And also sometimes gamma ray is emitted alongside other types of radiation. That is, when an atom emits alpha particle, excess gamma ray can also be emitted alongside with it. differences between types of radiations. So let's talk about the nature. So alpha particle is helium, beta particle is electron, while the gamma ray is an electromagnetic ray, not a particle. Let's talk about the charge. So for alpha is +2, for beta is -1, while gamma has no charge. The mass for alpha is 4 units, beta is 1/1840 units, and gamma has no mass, 0. Now, in terms of ionization power, the alpha has greatest ionization power, beta is lesser, and gamma is least. Now, in terms of penetration, that is penetration through obstacles, how the rays pass through obstacles. So alpha is least, then beta is greater, and gamma is the greatest. So alpha is absorbed by just thin sheet of paper, beta is absorbed by aluminum foil, while gamma is a thick lead block. Okay, so let's just talk about X-ray. These are electromagnetic waves created when the nucleus of an atom is bombarded by high-speed electrons. Now, here are a few machines used to detect the presence of radiation. We have the Geiger-Müller counter, we have the diffusion cloud chamber, and we also have the scintillation counter. Okay, let's talk about nuclear reaction. Nuclear reaction is simply the reaction that affects the nucleus of an atom, that is the protons and the neutrons. It is also known as radioactivity. Since it affects the nucleus, it affects the identity of the atom, as losing protons means a change in atomic number, since atomic number is the number of protons. I know if the atomic number has changed, the atom has changed. Nuclear reactions result in formation of new kinds of elements from previous ones. Remember Dalton's atomic theory that atoms can neither be created nor destroyed. This was modified due to the discovery of radioactivity, in which new atoms are created from old ones. So this is an example of a nuclear reaction emitting alpha particle. You can call this a disintegration or decay, radioactive disintegration or decay, in which a bigger atom breaks down to create a smaller atom by releasing a particle. Now this is also called transmutation, because we have changed from one atom to the other. So what is transmutation? This is the transformation of an atom into another atom through a radioactive decay process. So the new atom is called the daughter nucleus. Now let's talk about radioactive series. This is a continuous radioactive chain in which the daughter nucleus form decays into another daughter nucleus, and on and on. So from uranium through emitting alpha particle, we have thorium. So thorium now emits beta particle, we have protactinium, which can still continually disintegrate, and on and on and on. So this can be called the uranium series. Since it started with uranium, there are also other series of other atoms depending on the atom it started with. Okay, so types of radioactivity. We have natural radioactivity. This is the spontaneous disintegration of a nucleus due to its instability. So a naturally occurring atom, because it is unstable, it disintegrates. That is natural radioactivity. Now what is artificial radioactivity? This is when a stable nucleus, okay, naturally the nucleus is stable, but is bombarded with high-speed particles like neutrons, protons, deuterium, in order to make it unstable, and so it disintegrates. Okay, so let's talk about nuclear stability. What are the factors that affect nuclear stability? So number one is the neutron-proton ratio. If the neutron-proton ratio is less than 1 or greater than 1.5, then it becomes unstable and so will disintegrate. So let's pick a random radioactive element and see whether. So this is uranium. Let's check its neutron-proton ratio. We know that the proton is 92 since the atomic number is 92. So what is the neutron? Since proton plus neutron will give us the mass number, we know that what is remaining is 196. So that's a neutron. So let's test this neutron-proton ratio. So that we'll get that by dividing the number of neutrons by the protons. So neutron over protons, we get the ratio. So the neutron is 196 and we have 92. So this is 2.13. That is far greater than the 1.5 margin. This is why uranium is naturally unstable and will disintegrate. Okay, let's talk about half-life. So the second factor is half-life. Half-life is the time taken for half of a radioactive material to disintegrate completely. So a shorter half-life means more instability, but a longer half-life means more stability. That is, if the time taken for it to break down is very small, so just a little time it has broken down, that is, it means it's very, very unstable. So if it takes longer time to break down, then it's very stable. Nuclear force and binding energy. Nuclear force is the force that keeps the protons held in the nucleus as they would repel each other since they have same charge. So if the force that holds the nucleus is higher, it's more stable, and if the force that holds the nucleus is small, it's less stable. So higher nuclear force means more stability. So we also have binding energy. Binding energy is the energy needed to break the nucleus into its constituent particles. So if the binding energy is high, that means higher energy is needed to break the nucleus. That means the nucleus is more tightly held and more stable. And this also means vice versa, that if just little energy is needed to break the nucleus, that it is very, very unstable. So the three forces that affect nuclear stability are: number one, neutron-proton ratio, we have half-life, and then we have nuclear force and binding energy. So let's talk about nuclear energy. Nuclear reactions result in release of energy, and so humans have controlled radioactive processes to harness and use the energy from them. That's why we have nuclear plants, nuclear power plants today that use nuclear energy to produce electricity. So they do this in two ways. Number one is nuclear fission, and number two is nuclear fusion. Okay, nuclear fission is the breakdown of a nucleus into smaller daughter nucleus or different daughter nucleuses, accompanied by a release of energy. So the nucleus breaks into smaller daughter nucleuses with a release of energy, and this energy can be used for power. Now we also have nuclear fusion, in which two daughter nucleus are merged together to create one nucleus, also results in the release in energy which can be used for power. Okay, let's talk about half-life calculation. Hold on, what is half-life? Half-life is the time taken for half of a radioactive substance to disintegrate completely. Okay, so this is a useful formula to note, memorize, so you can screenshot it. So NO means the initial amount of the element, that is the radioactive element, while N is the final amount of the element. Okay, so K, which is the rate of disintegration, and we have T, which is the time taken. Okay, this is another formula. The half-life, which is presented as T half, that is the half-life, is equal to 0.693 over K. So let's take this example. The isotope of cobalt has a half-life of 5.27 years, What amount of a 0.05 gram sample of cobalt remains after 1 year? Okay, first let's write out our parameters. Okay, sorry, this is half-life. So the half-life given to us is 5.27 years. All right. Now the NO, which is the initial amount, is 0.05 grams. Okay, so what do we do from here? Now we know that the half-life is equal to 0.693 over the rate of disintegration. Okay, so now we have the half-life. Okay, so let's fix that in. 5.27 is equal to 0.693 over the rate of disintegration. So now let's look for rate of disintegration by making it straight to the formula, and we'll have 0.693 divided by 5.27, and this is going to give us 0.132. So this is the answer. The rate of disintegration 0.132 per year. So now that's not what we're asked to find. We're asked to find the amount, okay, after 1 year. So let's bring in our formula. So what are we looking for? We are looking for N, the amount after 1 year. So the time here is 1 year. So let's fill in the rest parameters. So we have log NO is 0.05 over N is equal to our K is 0.132. Our time is 1. Okay, so 2.303. Okay, so now log 0.05 over N means log 0.05 minus log N. Okay, so this everything here gives us 0.057. Okay, so since we are looking for N, let's bring N to this other side. So we have log 0.05 minus 0.057, bringing log N over to this side. We have log N. So what do we have here? Okay, so log 0.05 is minus 1.301, and then we have minus 0.057 is equal to log N. So what we have here on the left hand side, so all this together is going to give us minus 1.358 is equal to log N. Now this means that since log N is equal to this, that means 10 raised to the power of minus 1.358 is equal to N. So this is what it implies. Okay, so what is 10 raised to the power of minus 1.358? So this is 0.0438. Okay, so this will be the value of our N, 0.0438. So N is equal to 0.0438 grams. This will be our answer. This will be the amount after a year. So the answer is 0.0438 grams. Okay, let's take Jamb questions from topic 4. Question 1 is from Jamb 2003. The noble gases owe their inactivity to hexagonal shape, octet configuration, obtuse configuration, or cyclic shape. Now we all know that this is octet configuration because their outermost shells are usually full. Okay, so this is octet configuration. Now question 2, It's from Jamb 2004. So in this nuclear reaction, what is the value of X in the nuclear reaction above? A 226, B 220, C 227, and D 222. Now we all know that the alpha particle is a helium nucleus. So we can see that the atomic number is reduced by 2. Yes, that means the mass number is also reduced by what? 4. So that is, it will reduce from 226. If it reduces by 4, the answer is going to be 222. So that is option D. So that is option D, 222. So question 3 is from Jamb 2013. The radioactive emission with the least ionization power: A, alpha particle, B, X-rays, C, gamma rays, and D, beta particles. We all know this is gamma rays. Okay, so the answer is gamma rays. Now question 4 from Jamb 2021. The nucleus of an atom consists of A, electrons and neutrons, B, electrons and protons, C, protons and neutrons, and D, all of the above. The correct answer here is C, which is protons and neutrons. Question 5 is from Jamb 2013. The bond formed between two elements with electronic configuration this and this is what? A, metallic bond, B, covalent bond, C, dative bond, D, ionic. So let's look at the first one. The total number of electrons here is what? 2 plus 2 plus 6 plus 2. That is going to give us a total of 12. And this is magnesium. Okay, let's check the second elements here. 2 plus 2 plus 4. That will give us a total of 8, and that is oxygen. So magnesium is a metal, oxygen is a non-metal, and you can guess it right. It's going to be an ionic bond because it's going to be a transfer of electrons. Okay, thank you for 66 subscribers. It has been a very long journey making chemistry videos, and it has been an enjoyable one. Thank you very much. And if you're not subscribed, please consider to do that. God bless you.